So, good morning, class. Welcome to Sami Critic. So, today we'll discuss about the broad classification of biomaterials and their advantages, disadvantages, and some sort of application point of view. So, first come to the metal-based biomaterial. So, what are the characteristics of metallic biomaterial? So, they are basically high young modulus. They have high young modulus as well as they have good strength, good ductility as well, and they are biocompatible with the biological body. So as for the key features of a biomaterials is the biocompatibility. So in one word, they should not any toxic reaction with our biological system. So metal based biomaterials are very much biocompatible, high young modulus, good strength, good ductility, and basically they are formed by metallic bonding in the lattice structure. Now comes to the metallic implant part. Regarding metallic implant, so we can see that the advantages are for metallic implant. So they are strong enough. So what I showed previously, they are high young modulus. So they have high strength and strong in nature. So they can be used as a load bearing application easily. So the and relatively ductile, biocompatible, as well as corrosive resistance. They have high corrosive resistance properties, and they are also relatively cheap as well. So basically, stainless steel based alloy. So stainless steel is the alloy of basically iron, carbon, chromium, nickel, and molybdenum. So basically, chromium, nickel, and molybdenum act as a corrosive resistance properties, gives corrosive resistance properties in case of stainless steel. So disadvantages are, so they are susceptibility to crevice and pitting corrosion as well as fatigue and fretting. So they are much more prone to fatigue and fretting corrosion as well as pitting corrosion as well. But wire is less. So the corrosion due to the wire is very less because of strength and high young modulus. So for stainless steels, basically we have this kind of advantage. But other metallic based implants such as titanium or titanium aluminum vanadium based composite are very much useful in case of load bearing application. So for titanium, why we are going for the titanium part? So specifically low specific gravity, high specific strength, non magnetic properties, biocompatible with the material, and high corrosive resistance. So they have titanium based metallic implants are highly used as joint replacement, bone fixation, dental implant, pacemaker, artificially heart pump, stems. Almost everywhere we can use titanium based biomaterial. But in case of stainless steel, it is little bit cheap or cheaper than the titanium based metallic implant. Now comes to the ceramic based bio implant. So in case of ceramic based biomental, Their complex crystal lattice structure, amorphous in nature basically, generally high young modulus, brittle in nature, not ductile as well. What are metals are basically metallic implants are basically ductile in nature, but these are basically brittle in nature, inert or very much biodegradable, and they are basically formed by making ionic and covalent bond. So application of ceramic biomaterials are they are used as a mostly in case of oral prosthesis or dental implant. Also they have used as a hip joint in case of acetabulum cup, forming the acetabulum cup or the so that the femur head and acetabulum cup there is minimum amount of wire will take place. So where the bearing action is taking place basically, where the bearing action is taking place, there we are going through the ceramic biomaterials to make it strengthful as well as to minimum the wiring action. So most common ceramic biomaterials are alumina, silica and zirconia as well. Advantage: best high characteristics with polyethylene, high compressive strength and chemically inert and insoluble. But some disadvantages are also there, like low tensile stress is important, poor resistance, crack resistance, as it is very much brittle in nature and very expensive. Okay. Now come to the composite part. So this is the combination of two or more materials from the preceding families. Properties can be adopted by appropriate volume fraction and distribution of the different materials. So basically metal, polymer and ceramic. By combining three or any of two, we are basically making this kind of composite. So this is a good pie chart. So if you can go through, so basically 1 and 2, 1, 2 and 3. So 1, 2, 3 mixing of all, so we can getting that composite, or 1, 2, 2, 3, 1, 3. So this kind of using those features we are also going for composite. But using 3, this is basically the material which can be formed is very costly, highly expensive, and mostly they are using for advanced biomaterial purpose. Also some cobalt, cobalt, molybdenum alloy, or like what I discussed before, titanium, aluminum, vanadium. So these are the composite today's days we have used extensively. These are the alloy we have used as a alloy based biomaterial we have used extensively for load bearing application. So advantage: strength and corrosion resistance, and disadvantage: very high modulus and very much expensive in nature. But in case of bearing surface we have used it extensively, and metal on metal devices we have extensively used this kind of biomaterials. And polymer based biomaterials, basically they have a bind with the covalent bond, especially carbon carbon bond. They have van der Waals and hydrogen bond between the chain, amorphous and semi crystalline in nature, low elastic modulus as well. So advantage: tough, ductile, resistance and resistance to wear. Disadvantage: so as it is soft, susceptible to abrasion, wires, and weaker in case of tension. So the even the polymer based biomaterials today's days highly use, even in case of hip joint, even in case of knee joint, even in case of spinal joint as well. So those biomaterials are also used for aesthetic point of view also. So this is the broad classification of the biomaterials. So That's all for today, and tomorrow we'll go through the much more detailing of the application of biomaterials based on the problem also. So thank so basically, if we are going through that classification of biomaterial based on their advantages and disadvantages in a tabular form, that is mentioned here. So I am making that chart in a brief way so that it will be much more understandable for others also. So basically, the polymer based biomaterials such as nylon, polyethylene, silicon, Teflon, Dacron, and polyglycolic acid and polylactic acid. Those are very much resistant and easy to fabricate. So they are basically, if I am dealing with the fabrication process, it is easy to fabricate. But disadvantage is not strong. But uh, we have to understand that if the material is not strong enough, then it is very much easy to fabricate or machinable also. Basically, the strong or strengthful materials which are not deform easily, not e- they are not easily moldable. So this is the basic advantage and disadvantage of polymer based biomaterial. But examples, so where we are apply, this is the application part, not only example, we can say it is application. So where we are applying this kind of material for structural vascular graft, hip socket, intravascular and lenses. Now come to the metal based biomaterials. So metal based biomaterials are such that titanium and its alloys, cobalt chromium alloys, stainless steel, gold, etc. Strong, tough and ductile as well, may corrode, dense and difficult. Joint replacement, bone plates and screws, dental roots, implant as well. So this is the main metal based biomaterials. Those are used as basically those are used as a load bearing application due to the strong strength and ductility. They are much more, their Young modulus is higher, strength is better and ductility. But the disadvantage is they may corrode for because of pitting corrosion is very less, dense and difficult to make. Now comes to the ceramic part, like aluminum oxide, calcium phosphate and carbon. So advantage, very much biocompatible, inert, strong and cohesive. But disadvantage is brittleness, not easily moldable, difficult to make. So similarly here the applications are for dental implant, femoral head, hip replacement, coating and dental and orthopedic implant purpose. And some composite kind of thing is carbon carbon, ceramic polymer, carbon reinforced polymer, fiber reinforced polymer, glass reinforced polymer. They are very much strong, less stiff, but their cost is also more. Difficult to make in weak in tension. So they are basically joint implant, means load bearing application and dental filling. So this is the all about advantage and disadvantage of biomaterials. Thank you.